Hello, and thank you for listening to this episode of the Night Sky Podcast. My name is Billy Newman,
And I'm Marina Hanson.
and this week we're going to be talking about some of the news, sky events that are going on in the night sky above us for the third week of January, and now 2017. How you doing, Marina?
I'm doing well. It's cool being in the new year.
Yeah, I think it's really cool now being in 2017, finishing up 2016, coming into the second year of doing the podcast, which is kind of fun.
Yeah, it's cool.
I think we'll do a few more of them this year, but it'll be fun to kind of hang out, chat a little bit, and talk more about the things that are going on that we see in our observations of stuff going on in the night above us. But it's cool checking out the sky, and I really appreciate a lot of the stuff that I've learned so far from doing this podcast, and some of the things that I've kind of been inspired to research from it.
Yeah, it has been cool having more of a reason to try to find out other things. It's been cool. I've learned a lot more than I was expecting to.
That's really good. I'm glad that. Yeah, I was wondering. I was trying to think over this last year of different things that we've learned about. What have you learned a little bit about? Like you've learned
It
a
was
lot
really
this year.
cool. Yeah, it was really cool watching Mars this last year with all the movement it had and kind of learning more about that. And
Mars
how,
was great this
like
last year.
retrograde and prograde works and
Yeah,
just all that.
that's really fascinating. I really appreciate talking about and getting to look at the retrograde motion that Mars was doing. That was really cool to see in like the middle of the summer the way we
Yeah.
did. Just gets so hugely bright. It was cool. And then now, what do you think about watching the planets, how they've moved about each other over the course of a year now that like we've both been trying to pay attention to the locations?
It's interesting seeing the patterns and how they move around. I feel like I need a few years of
Oh,
watching
sure, yeah,
them
you
move
do.
around to like really notice how it goes.
I wouldn't expect you'd have and I don't have any real sense of where they're going to be almost, but I
Mhm.
do notice how strange it is though, like thinking about maybe 16 months ago, when we saw Jupiter and Mars really close to each other in the morning sky or like late
Yeah.
night sky, and then how far apart they'd moved, by another time of the year, or how they'd come together again. I think about 1 year ago now, we had Mercury coming up and we had all 5 of the planets up in the morning sky. That was one thing we were
Right.
talking about this time of year. And then now they're nowhere near each other, at least in that regard. So it's kind of interesting coming back now and seeing where they are, how
Yeah.
Venus is in the night, Mars is in the night sky, Jupiter's in the early morning sky, Saturn's going to be in the early morning sky. It's interesting just seeing how they kind of spread out again, but then now they'll come back together in some, or there'll be different ones that are closer and further apart to each other. Like right now we have Venus and Mars pretty close to each other.
Yeah, they are pretty close.
And it's interesting, especially like you're talking about with Mars, sticking on that for a second, how much that's changed over the year. And just getting to observe that must be really interesting because we saw it at its very brightest.
Right. It's pretty dim now.
Yeah, and then now it's significantly more dim. Like I think it's a
It's-
drop of 4 magnitudes to whatever that is.
Yeah, it's quite a bit dimmer, and especially compared to Venus, which it's next to now.
Venus
which
is
really bright.
Hugely bright now. Yeah, it's so bright. It might be at one of its brightest showings. And
I feel like it must be. I feel like
Oh,
I
yeah.
haven't really noticed any of the planets
Oh yeah,
this
it's
much
maxing
before.
out.
It seems so bright. Especially I think just a month ago, there were some really clear nights in Corvallis when I was up visiting family, and it just stuck out in the sky so much.
Oh,
Like
yeah.
it almost feels like you can feel the light bouncing off of it.
Oh yeah, I bet you could. If it's significantly more dark, you could probably see your shadow. Like with Jupiter or Mars, when it's that bright, you can see a shadow cast from it, from the light
Wow.
from another planet, a Venusian shadow.
That's cool.
Ooh, yeah.
Venusian?
I think that would be how you would, if you lived on Venus, you'd be a Venusian.
Oh, gotcha.
If you lived on Mars, you'd be a Martian.
Martian.
Perhaps. Maybe I'm wrong. Maybe Venusian is like, I don't know. It sounds like the Venetian. But I think it's all, it's both Italian, right? Or Rome or some Latin, from a Latin root for Venus. But I think, right now, like you were talking about, I think Venus really is coming into one of its brightest sections. Like right now, it's at a negative 4.6 magnitude.
Yeah.
And it's coming up. It was just at, I think, 4.5 like the week or so in the past. And there's an interesting thing I was learning from that book we were going through, which I'm sure we'll get into a lot as we read through it and maybe check out or kind of research different things that we get interested in from it. But this first thing was about Venus and about when it's the most bright. Because like we talked about Venus before, is it's an interior planet, right? So the same way we see a lot of variability with Mars and how bright it is in the night sky. You know how like when, like right now, it's pretty far away from us. It might be on the far side of the sun from us. So it looks a lot dimmer in the sky, in the evening sky. But in the summer, when it came up and it was at opposition to us and it was close and it did that retrograde loop, that was at its closest point to the Earth. And so it looked really, really bright to us. And so it's interesting because with an exterior planet, and I'll explain this first and then I'll get to Venus. With an exterior planet, what we're looking at is the whole broad face of that planet surface illuminated by the light of the sun, similar to like how we look out to the moon and see a quarter moon or a half moon or a full moon. Is that there's a whole surface of that showing us light. And so it's interesting that for us, when we look out to planets that are past us in the solar system, they kind of behave a little bit differently. Now you can probably still see them at times where they're not totally full, but you won't see them at a point where they're a crescent, if I understand correctly. They don't get way more dim to us because they won't ever be inside the sun from us. So we'll never really see on the shadow side of the planet.
Oh, right.
We're always going to be looking out past us from the center of the light source, the sun, to a point of light where we're not going to see that shadowed spot. Like we see the dark side of the moon, or we see the shaded section of the moon when it's a new moon, and the light is on the other side of the celestial body of the moon. And so since the moon is in front of us in the sun, it's darkened in our perspective, yet there's still half of the moon lit by light from the sun on the other side. Does that make sense?
Yeah.
Yeah. So it's interesting when you think about that. So when we're looking at Mars, we see variability in its light because of that. And we look at it in a different way. But when we look out to Venus, there's this other characteristic that we see. And that's with planets that are interior from the Earth toward the sun, those interior planets of Venus and Mercury. And what we get with them is a different orbital path. Like that's why we never see Venus rise deep in the night sky, go up to its zenith point, and then set sometime near sunrise. Like if Venus could be at opposition to us the way that Mars and Jupiter and Saturn can. And it can't because it's going to be inside the sun from us. So for something to be at opposition, for something to rise at sunset, it has to be directly straight out from us and the sun if you were to draw a line between those things. It'd have to be directly straight out past the Earth to rise out in the evening sky from the eastern horizon. So that's why we never get to see that. We only get to see it sort of close to where the sun is in the sky. And so we see it come up like we're seeing it right now in the winter sky, rise each night a little higher and higher on the western horizon until it hits its greatest elongation, and then it's going to come back down toward the western horizon and go out of view. And that's going to be its season of being visible to us. Then what we see is in the morning, just a few days later, it shows up in the morning sky after sunrise, meaning that it's past the sun and then is now on the morning side of the sky where we're only going to be able to see it before the sun rises over the eastern horizon. Interesting how it goes back and forth. Now, this all gets back to that thing I mentioned a few minutes ago, why it's getting so much brighter now and when and in what state we see it at the most bright from our position here on Earth. So get this a little bit. So do you know how with the moon, there's a full moon and a crescent moon, right?
Right.
And so for us, the brightest moon is when it's a full moon.
Right.
And the dimmest moon maybe is when it's a crescent moon.
Sure.
But this doesn't, yeah.
I was just going to say, because less of the surface has the light reflecting on it.
But this isn't the same characteristic that we see with Venus. And it's kind of strange like this. So what apparently is happening, maybe I should double check this, but what apparently is happening is that the crescent side of Venus is getting so much closer to Earth that it's getting a lot brighter. So even though if you were looking at Venus through a telescope, we would see most of a crescent because it's inside of our Earth's orbit toward the sun, and it's going to be passing kind of in front of the Earth and the sun. It's going to be kind of a crescent shape when we look at it. And that's why it's getting so bright. Not because it's a crescent, but because the planet is actually physically really close to us. Sort of like how Mars was really physically close to us.
Right.
But it was rising at opposition and showing itself to be really bright. So imagine this for a second. If we had the sun in the center. If we imagine the solar system, we imagine ourselves here from a perspective of Earth. And then we imagine just a little ways out, maybe in the middle of that, there's this imaginary orbital line that goes around the sun with the planet Venus that stays on that track. And so as it's swinging on the inside of the Earth from us, we see that crescent. And as it gets really close, it gets significantly brighter in magnitude from our visual perspective here on Earth. And I think, if I remember right, I think Galileo is one of the first people to actually document in his notes the cycle of Venus, or this crescent cycle of Venus.
Oh, interesting. Okay, Galileo.
Well, yeah, one of the first. There was understandings of Venus cycles from much earlier on than that, because people could actually see in some instances that it wasn't actually a full shape of Venus, but it was a crescent, in fact.
Oh, that's interesting.
Interesting stuff, yeah. But since Galileo had the telescope, was making observations of the night sky, these were one of the observations that he documented. Pretty interesting thing. But it shows, similar to like what we're talking about, it moving from a period of being a crescent shape to a half shape to maybe what's close to a full shape, but not maybe a total full shape. Because if we think about this, like what I was saying a minute ago, we construct this mental model of the solar system. We're on Earth. We look out toward the sun. We see Venus there kind of halfway. It's passing on the inside of us. We see that crescent. Right now it's really bright out in that crescent. But we think like in other planets, or like with the moon, when it's full, we would see it at its most bright. Not the case with Venus, because for our instance, since Venus is inside of our orbit of the Earth, when it's full, it would be on the far side of the sun, much further away. And that's the only time we'll see the light source illuminate the full face of the planet Venus to shine back at us.
Oh, interesting. Okay. So when it's at its brightest is when it's actually just physically closest to us.
When it's physically closest to us.
That's really interesting.
Yeah.
I hadn't thought about that, or I didn't understand that was quite how it worked.
Yeah. I was trying to figure this out too, because I wasn't sure if it would be one or the other, or, mentally when I'm thinking about it, it's like, well, wait, would it be brighter to us in our perspective when it was full, or maybe like half full or something, kind of swung out to the side 90 degrees and we see a lot of it there? Or would it be brighter as it gets closer to us, but we see less of the illuminated surface of that disk? And it's interesting to find out that as it gets closer to us, we're really seeing more of the illumination. Now, when it is closest to us, it will be right in line with the sun, likely, as it kind of comes back down and gets real close to the sun. That's why when we look out from Earth, we see straight up to the sun, but then we see Venus there. Do you remember that transit of Venus we watched?
Yeah.
After the eclipse in 2012 in June, we took that smoke glass out of that coffee shop. They said, hey, it's happening for the next 8 hours. Go out. And we saw that transit of Venus cut across the sun. It's so interesting. So that's a situation when we're in a position of syzygy. That's a really strange word to spell. I think it's like syzygy, S-Y-Z-Y-G-Y. Oh, yeah. It's a cool word. But it means when three bodies are aligned in a row, or like three celestial bodies. So when we look up, it's the Earth to Venus to the sun directly. And that's the time that's going to be in a straight line. So if we imagine that same celestial model, we'd kind of swing. In our instance, it seems like Venus would be kind of out to the side from us. So still getting part of it illuminated, part of that sphere illuminated, but still looking like a disk to us.
Interesting.
Yeah.
Is a syzygy, is an eclipse a syzygy?
Yes. An eclipse is a form of a syzygy.
Are there other forms of syzygies? That's hard to say.
I'm sure there are. I'm not really sure, though. I don't really know how it goes or what really accounts to it. In fact, even this thing of a transit of Venus may not be a syzygy geometrically. Maybe it is just from my perspective from this spot on Earth. But it seems like that would be the time that is happening, when either we're at a position of new moon, like the moon is straight in from the sun from us, or when we're positioned at full moon, when it's swung 180 degrees in the other direction to this farthest away position, it's still being aligned. So it's kind of interesting how it goes. But so with the moon, we get it a little bit more often. And I think with other objects, we get that too. But I'm not really sure what in all capacities what it means. But it is interesting though.
Yeah.
Seeing how that
cool.
is. Yeah. Yeah. It was kind of neat. So that's why we see Venus is so much brighter at this time. And it's really cool because we're in this section where we're having this wide swing, or this, it's it's a long elongation of Venus. So it's going up pretty high into the sky. And the cool thing is, especially right now, is that it's the winter time. So that when the sun sets early, Venus is still really quite high into the southern sky. For a lot of the stars that are going to be up there, we really can look up pretty far up from the horizon and spot Venus because the sun's setting so early and because it's going to have so much time in that dark sky to pass down to the horizon. And that's why we've been looking at what really seems like an especially bright Venus, when maybe at times in the summer it is close to the same magnitude, perhaps, let's say, but the sun sets so much later in the northern hemisphere here. We have such brighter skies later into the evening, a longer period of twilight while the sun is on this half of the sphere of the globe. Does that make sense? So when the sun in the summertime, like if we lived in Alaska and it was nighttime, it may not actually ever get pure dark.
Right.
Because there's still going to be a bit of light coming up because the sun's so much closer to that part of the earth. It's really only dipping down a bit.
Right.
And then
not
coming
fully.
back up. And so what we suffer from in the summertime is an illuminated northwestern horizon line.
Right.
And that in part impinges on the brightness or the luminosity, the luminance that we would see from Venus when it's showing itself to be very bright.
Yeah, I think it was like last year. It was Mercury. It was kind of hard to see in the morning.
Right. Yeah. Mercury.
For that reason.
Yeah, that reason. Yeah, because it is still existing and is bright.
Yeah.
But it's just difficult for us to see because
we have all
our atmosphere
too.
Yeah, it's getting in the way. And so that's part of it. And that's why people like to make observations deep in the night when things get to their zenith point, when they get kind of straight up, because that's the smallest amount of oxygen or atmosphere for our eyes to look through to get out of the atmosphere. Why we fire rockets straight up instead of sideways, I suppose. Like I think the atmosphere is somewhere around like 100 miles to get up, like to the space station's orbit. But then if we think about it, when we can look out across the land 100 miles, we can look mountaintop to mountaintop, and that can be well over 100 miles. So we're looking through so much more atmosphere when we look laterally across to the horizon. And this is actually the reason that we see sunsets, we see haze or mist, or we see bluing in mountains. Like if we see a range of mountains that are close to us, that are green, further away, they're bluer or more hazy or something.
Yeah, they become more cool toned.
Yeah, and that's actually the atmosphere, the thickness of the atmosphere stacking up as it gets further and further in distance. And also, to continue on that, there's more particulates in the atmosphere at those lower levels. And since we burn things and we pollute in some sense, and since we kick up dust, and since there are forest fires and all of those types of natural instances in weather that move up a lot of material, there's a lot of a density of distance and accumulation of material in those lateral directions. That's why it takes about 15, 20 degrees before it seems to get real crisp in the air if you're looking at kind of around the horizon line. It's kind of interesting.
Yeah, that's neat.
Yeah, it was pretty cool. I like kind of think about a few of those things. But yeah, it was kind of interesting about how that is and or just how much better it is when you look straight up into the air, into the night sky. It's a lot darker. But so there's Venus. It's really bright. And then just up from Venus is Mars. Had you checked out Mars a couple times?
Yeah, I've seen it a few of these nights.
Yeah. Well, now tell me about like what you see as being a lot different about it now than what we saw in the summer.
I noticed it's a lot dimmer.
A lot dimmer.
That's a big thing I noticed.
Yeah. And isn't it strange how it's still up in the sky? It was in Scorpio, but Scorpio is nowhere near up right now.
But it's near the sun. Here.
So the reason that we were able to see Mars in opposition in Scorpio during May and June this last year, but now we see Mars in Aquarius, where Scorpio has now moved on to being up early in the morning. Now it's like Sagittarius and then Capricorn that are in the position of where the sun is. That celestial position of the zodiac has kind of passed on. So now, since I think Saturn's still in the position of Scorpio and then moving toward Sagittarius, but what we see is Mars being in a much dimmer position in the constellation of Aquarius. And it's interesting when we look out there because I think Venus is pretty close to Aquarius. Maybe it's Aquarius to Pisces. I think maybe in that no man's land between those two constellations.
Yeah, I think so. It's interesting that it's stuck, or that Mars has just been in the sky for so long. For
as long as it has been. Yeah. It's a very peculiar thing.
Yeah. How does that usually go? Or how
Well,
long do you usually see the different planets?
see, this is an interesting
it-
thing about what we're seeing with Mars and its position right now. And Mars does have a different track through our night sky than what most of the other planets do. And historically, this has a lot of significance too. It's why Mars and Venus were kind of pulled out as a little bit different from the other planets in their walk about the or about the night sky. Part of it because Mars is retrograde action, and then it's continued, like we're noticing now, it's continued prograde motion through a lot of the stars, quick enough to stay up in the night sky, or up in a certain case in the morning sky, staying out of view in the night sky for years almost.
Yeah.
Imagine, or there can be a significant section where, like what we're watching now, where it's been in the evening sky for the better part of a year. There'll be another part where it's out of the evening sky, and it won't track the same way that we look out at Jupiter with, where it's still pretty close to the same position, not year over year. It moves a good bit, but it does, as it moves, we're able to track it. It kind of comes up at about the time you'd expect.
Yeah, it has its little pattern.
Yeah, and Mars definitely has a pattern to it. But as what's happening right now is, since the Earth is inside, like we're talking about Venus, since the Earth is inside, it's moving a little bit faster. So it's pulled away from Mars. When we were really close to each other that time in June, when we were at opposition and we watched Mars do that retrograde loop. That's as we watched it do the retrograde loop, that's right as the Earth passes it. And then now Mars is still following us in the sky. And so that's why it's pulling up back the sky. So even as the Earth has changed its seasons, Mars is still chasing us like a car trailing in a race. It's still chasing us. And so that's why it's kind of dragging up through Sagittarius and through Capricorn and now through Aquarius and into Pisces, because it's still kind of pulling up toward the Earth. So it's going to be kind of interesting to watch. I think it's going to set, I don't know, here in a month or two or something, and it'll be down for a while in the sun and then up in the morning sky. And then it probably won't be until, I don't know, until like maybe spring of 2019 that we see it pretty significantly again. I wonder what it'll be. Yeah, it might be, it'll be a year for it being pretty dim. We're not going to have a big bright pass of it for really quite a long time. So now I think when we look out at Mars, if we were to look out tonight and we see Venus in the sky, just up to its left, if we kind of track that zodiac line, or that planetary, that plane, we'd spot Mars there. And I think that's at a positive first magnitude. So I think it's the same as another first magnitude star.
Wow.
Yeah.
Yeah, it's so much dimmer.
Yeah. Yeah, a lot dimmer. So I think in the summer we saw like 4.2. Venus, I think, is the brightest object that can appear in the sky, which is, I think, close to what we're seeing at its maximum at 4.6, negative 4.6 magnitude. So we saw Mars at an almost similar magnitude of brightness this summer. Now we've seen it drop off so much, nearly 5, I guess, from -4 to +1. It's been like a really big swing. And then now it's going to get even smaller at times. And there's certain times of the year you can spot it and it just really looks like a little speck in the sky. You think, that's Mars? It was so huge and big. And it's weird because we don't see that same variability with Jupiter, which is why Jupiter is sort of regarded as more stable and more steady, and its path through the solar system, or its path through the night sky and the stars in the background, is much more steady and even, similar to how we see Saturn. But with Venus and Mars both, you see that chaoticness of it.
Yeah, that movement.
And I think that's why men at the time historically associated Venus and Mars with chaotic entities.
Mhm.
Mars associated with war, which is very chaotic. And then a more of its time thinking, women were associated with Venus, who I guess in their perspective were quite chaotic as well. But it's interesting the connections of how different cultures kind of associated those two.
It is
aspects to things.
interesting. I thought it was interesting that it's those two planets also, because those are the planets that are the ones that are right next to us.
Oh, sure,
Like,
yeah.
Yeah, Venus is the one that's in from us. Mars is the one that's out from us in our line.
And I think that is kind of perplexing too. I don't know if that was well understood. In fact, the heliocentric
I
model
imagine it wasn't,
was not well
but I
understood.
think it's interesting now. That those are the ones that
Right.
that happen to be next to us, and also the ones we happen to notice more behaviors of.
Yeah, in antiquity, if I understood some of the things I was reading right, the way that they classified it was what moved most quickly was closest to us, and what moved most slowly was furthest away from us.
Okay, so they probably kind of understood or believed that those things were closer to us than the other ones.
Yeah, I think that was pretty well understood. I'm not sure where they placed Mercury in the mix, but I think it was, or excuse me, what moved the most dramatically in the sky. So like Saturn, like we were talking about, is really quite steady. It takes 27, 28, 29 years or something to make its full year trip around the sun,
Right.
and its full year trip through the night sky for us. Jupiter takes 12 years. Venus takes, I think, 200 days. Mars takes, I think, 500 days. So I think that's sort of how it was understood. It was kind of interesting how that was. I think maybe it was Aristotle or Plato that I might be like they were the one that classified. Well, this is moving more, so it must be closer to us. I guess like you would think of things on a physical plane. You know, if it was just you and me, and then maybe another person 100 feet away and another person 1,000 feet away, you would have to move just very little for me to notice a significant amount of movement for you.
Yeah.
But that person 1,000 feet away would have to run back and forth 50 feet each time to kind of have me notice like a significant amount of change from my perspective. So it's kind of interesting. So I think they try to take that same understanding and place that onto an Earth-centric model of the universe, which would have been very difficult to try and understand all these motions of the planets, how things moved around. My goodness, what a terrible time that would have been. So confusing.
It would be pretty confusing.
Yeah. But thanks for talking about some of the planetary movements. It's kind of cool.
Yeah, it's interesting seeing this change or seeing how things are kind of different this year from last year with how they look.
It is really different. I've been thinking about that too. But it's cool kind of keeping track of it. And that's what I like about covering stuff about the night sky, is the different ways that it changes. And there are new things to see, and there are new kind of connections and conjunctions of things that I think are kind of what makes it continually interesting to get into research. And there's a lot of historic stuff I want to try and bring into the podcast too in the future.
Oh,
Like,
me too. I've been having a good time reading the start of that book.
I like it a lot too. Yeah, I like learning about archaeoastronomy.
Yeah, that's what I was going to say too. I like that part of it. It's been really interesting learning about like the more cultural meanings of things and like why those things were thought about or understood in the way that they were.
That's a big part of why I had always connected with the stars and with understanding where they are in the mythology and just watching the night sky without a telescope. I'm not really so interested as much, like we've talked about before, of the celestial bodies you can view with magnified optics, but I really appreciate looking at the way that the shapes of the stars are and how they move across the land and different things you can kind of tell. But there's so many complex pieces of how our world works that are sort of tied into esoterically into the way the planets move, the way the stars move about the year, and sort of understanding that from the perspective of an ancient person, I think is really fascinating. Some of the stuff like we've learned about the Mayan culture has been really interesting, in their connection to Venus. I really want to go through that in an episode of the show with you.
Yeah, I think it'd be cool.
It'd be really cool. Jupiter's connection to the Chinese New Year, I think, is really fascinating.
Oh, yeah.
I want to talk about that. And Chinese New Year's coming up soon, so maybe we can talk about that again. We talked about it last year, but now there's more things I know about it.
Yeah.
It's kind of,
cool.
you go, wow, oh, is that? Oh, well, that's easy. Of course they would have done that. We're learning about the 28 lunar mansions in Chinese, because it takes the moon 28 days.
Oh, right, for its cycle.
To go through the month, yeah. And so there's 28 homes that the moon resides in. And those are the constellations, like where we have 12 zodiac constellations.
Right.
They had 28 lunar mansions, these homes of the moon to stay. Yeah. Yeah, very interesting. Yeah. So just kind of interesting different perspectives of the way that the different cultures kind of piece the way that their stars worked. But really fascinating to sort of glean a little information of how they understood things and what they made sense of. Very, very fascinating. Like the Mayans had a different start of the year. Like, of course they would. I think since they're equatorial, they built a pyramid with a hole in it to decide what the New Year's date was. And so because they're equatorial, there is a day of the year on the solstice, I assume, where the sun is going to be at its zenith point. When it comes up to its highest point in the day, it will be directly overhead. There will be no shadow. And so they built this pyramid. They built this whole object, this temple, to have this column in it so that the sun would pass up, and then on one day it would shine directly down this column and prove that it was the first day of the year.
That's really interesting.
Very interesting. Yeah. But it was probably the solstice, or, it was one of the solstices as it was.
How interesting.
Yeah. Others like Stonehenge. And then there's these other Native American camps that have been found where they mark lunar standstills, the point where the moon or the sun gets to the highest point to the north or south, and it stands still for a second near the solstice. I think it moves slowly, and then it comes back down to a point where it's at the equinox, centered, and then goes back out to its southernmost lunar standstill. Very interesting. But yeah, there's a Native American a location that shows this. It's like it's like a position, and then there's like these two mountains, like these two like pillars in the desert, that come up, and it's sort of organized so that this one is for the moon on the solstice, and then this one's for this thing.
Do you remember which tribe or which like section of the country that was around?
I'm not sure. I think it's in Arizona. It's in the Southwest.
That's cool. Yeah. I want to learn a little bit more about that.
Yeah, I'm not sure which tribe it was, but I know there's a few that had territory in that area. But yeah, but pretty interesting, and similar to how Stonehenge is constructed, where if you're in there, it's a way of understanding the calendar of the year around you by seeing where the sun rises and stuff. So really interesting stuff how that works. I was always fascinated about those types of things and other elements in culture that are like that. It'll be fun. I want to talk about that a bunch more with you.
Yeah, I think it'll be really cool.
I think it'd be pretty cool too. But yeah, is there any other stuff you want to talk about? I think that kind of covers a good bit of stuff for the week for us.
Yeah, I think that wraps up this episode pretty well.
Yeah, thanks so much for doing this episode of the podcast with me again.
Thanks, Billy.
Looking forward to bringing back a bunch more talk about our evening observations of the night sky.
Yeah, me too. I'm excited for it.
Yeah, it'd be fun. We should do this a lot. This was fun and easy.
Yeah, it was good.
Well, thanks a bunch, Marina. And thanks a bunch to everybody for listening. You can go to nightsky.io to check out our website. That's where you can see a whole list of the podcasts that we've done over the past year or so. And you can check out some more information. Shoot us an email if you'd like. That'd be kind of cool. I'm sure our emails are listed in there somewhere. You can check out other stuff of ours, I guess, at billynewmanphoto.com. You can go to Instagram.com. It's at Billy Newman. Marina, it's at Marina Rosales. And yeah, Marina, thank you very much for doing this episode.
Yeah, thanks, Billy. Thanks for recording with me.
Ooh, I appreciate it. It was cool talking about these planets and stuff. I had a good time. So, on behalf of Marina Hanson, my name is Billy Newman, and thank you very much for listening to this return episode of the Night Sky Podcast.